Okay guys, in this video I want to talk about Coulomb's law and different unit systems. I think this video might be helpful to you because if you're looking for some additional information online, you might see Coulomb's law written in some of these different forms, and the only difference is the unit system that the people are working in. And in fact, it's more common to use another unit system than we're going to learn in this class if you're really doing electromagnetic theory. Okay, so I'm just going to do one big slide here. You can pause it if you want to take notes, or, this isn't necessarily something you have to take notes of. It's more just something helpful to remember. So in this class, we're going to be working in the SI unit system, which is what you guys have been working on in most of your physics classes. And in SI units, this is the most typical form of Coulomb's law. Here, you've got this constant out front, which is the thing that's not always there. The 1/4 pi in that constant, the reason why that's separated out from epsilon naught has to do with the fact that we're often going to be working in spherical units, and having a 1/4 pi in the equation kind of can normalize that spherical unit. It's convenient when you're working in spherical coordinate systems. The epsilon naught, that is called the permeability of free space, or it's basically this number that describes the ability of an electric field to permeate into a vacuum. So it's just a number, it's a constant. If we lived in a different universe where for whatever reason it was harder for that electric field to basically move into a vacuum of space, this epsilon naught would be a different number. But it's kind of a silly name for a constant, as the book describes, but the permeability of free space, what that's trying to say is this is something that describes the ability of the electric field to permeate or spread into a vacuum. Okay, the charge in our SI units, that's measured in units of coulombs with the abbreviation C. Distance is meters, abbreviation M. Epsilon naught, that permeability of free space, I'm going to let you guys figure out the units of, and force is in newtons. So you guys should be familiar with that. In the Gaussian unit system, Gaussian units is a more commonly used units in electromagnetic theory. It's kind of designed to be done. It's kind of the reason why Gaussian units were originated was for electromagnetic theory. It's part of what's called the CGS unit system. So CGS stands for centimeters, grams, seconds. So those are the base units of those particular quantities. The difference in Coulomb's law is you don't get this constant out in front when you're working in Gaussian units. Okay, so you might see this form of Coulomb's law out there, but the charge is measured in a different unit. Basically, this Franklin or Strato-Coulombs, that unit is normalized to absorb that constant, the 1/4 pi epsilon naught out front that we see in the SI form. Okay, so mathematically, if you're doing a bunch of theory, doing a bunch of calculations, it's just nice to get rid of that constant. When we deal with Maxwell's equations, this is actually going to have the speed of light c showing up in Maxwell's equations where it wouldn't in the SI unit system. Okay, if you're working in Gaussian units, distance is in centimeter, force is in a unit called dynes. And again, the whole point of this unit system is it's what we call rationalized or normalized to make it more convenient when you're doing mathematical electromagnetic theory. The last unit system you might see it in is the Heaviside Lorentz unit system. This is most commonly used in something like quantum field theory, so some really kind of more modern, higher level theories. And I'm not going to go over what the individual units are of these things. There's no way we're not going to deal with this particular unit system at all. It's less commonly used as well. But again, this is for convenience of people that are actually doing the theory and the math, developing these new physical theories. The units in this particular system are normalized. You can tell here there's no epsilon naught in this constant out front. So the epsilon naught, it's not a very good epsilon naught, I'll fix that. Epsilon naught, as well as the magnetic permeability, which is mu naught here, those are all equal to 1. And also in this particular unit system, the speed of light would also be equal to 1. Okay, so those are the 3 unit systems you guys will most commonly see if you're doing some research here. In this class, because we're familiar with it and we're trying to learn, we're going to use the SI unit system.